Okay. Hi. So my name is Sam, and I do machine learning. Oh, crap. Okay, take two. All right. So my name is Sam, and I do machine learning crap. Anyways, um, there's this thread in the Julia discourse about the state of machine learning in Julia right now, and lots of people have chimed in with all kinds of different stuff. I wrote a comment here at some point talking about some of my experiences, but I thought it would be interesting just to do a video, just me trying to implement just the simplest possible thing in Julia. So MNIST model. Uh, Full disclosure, I uh, I use Python and JAX most of my work. We did have this. I did have this paper last year on continuous time policy gradient stuff, where actually we started off trying to do it in Python and JAX, but we were limited to sort of what we could do in XLA. So we switched over to Julia and went from there. So, and shout out to the differential equations.jl package. But I don't have any experience with like kind of, traditional machine learning in Julia. So that's my only project. I don't really have a horse in this race. Um, I think Python and Julia are both shit, and we should go back to pen and paper. But other than that, it's what we have. So uh, my thinking is I'm going to set a timer for 1 hour on the phone, and then we're going to try and go from 0 to working Julia MNIST classification. Fingers crossed. So I've never used .jl or whatever that crap is. So we'll see how. All right. Woo. Clock. Timer 1 hour. Okay. And we are, oh, wrong one. We are, okay. Let's do it. Um, okay. So I use this tool. This is an aside, but I use this tool JJ that I wrote to spin up EC2 instances, resize them just the way I need. So we'll do one of these. So my prediction is it's going to be not too bad, since MNIST should be really, really, it's the easiest possible thing. But the goal, I guess, is to sort of do like a user experience study of sorts. So we'll see what happens. Okay, we're in. So let me make this big, people watching one day. This is the first time I've ever streamed, so I have no fucking clue what I'm doing. Okay, all right. Um, so create a new thing. Streams. Uh, commit. Let's make one flying ostrich. Okay. So, okay, let's get some basic stuff. So first, let's pull up top secret. Let's pull up a basic shell.nix file. Host do to folder. Okay. Okay, great. So put this in here. Okay, so that looks good. Hide that for now. Okay, this, but we don't need any of this or this yet, so we might. Okay, let's see what we got. So, that's visible. Okay, so we'll enter the next shell, and then Julia. Okay, so how do I want to do this? Let's start with a pseudo thing. So, ooh, actually, I don't want to do that there. I want to do that over here. Okay, so we got running. Pluto has some bugs in Safari right now, so I'll use Chrome. Okay, and here we are. New notebook. Okay, this is to understand about Pluto. It takes forever to do the simplest, like just to load. It also depends what browser you're in. Like to load those things down there, it's slower in Safari than it is in Chrome. I have what? It makes no sense. I don't know. I don't get it. Okay. All right. Let's import Flux and see what that does. Okay. So I think to start, I only really know of Flux. So that's what I'm going to try to use. But I have little faith in that being like, I don't know if that's the right choice or not at all. But I assume they have like tutorial. Yeah, tutorials. Okay. GANs, no. I just want simple. Just give me MNIST model zoo. No. I just want the easiest thing. 6-minute blitz. I don't want. Oh, okay. 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 That's just a data layer though. I want model. Let's start with the. Okay. So it's still falling. Okay. Consider simple linear. Tries to predict y. Oh, blah 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 blah. Okay. So we write some. This is not really telling me anything except how to implement a function. Params. So this is something special. It looks like params. Okay, so the magic here, because okay, the predict is uh, some function. It closes over. It has these sort of captured variables w and b, and traditionally, the way that I would understand this is that like you capture these in scope, so you have some closure, and then either copying these in by value or by reference, we have some access to W and B. But here, what they're saying is there's some kind of magic where params is affecting the closure for predict without anything explicit. I don't like that. That's weird. I wish I understood how that part works. guess it's cool maybe, but like the nice things about JAX is that everything's very explicit. Like, all of my parameters are wrapped up in one thing, and my entire sort of system, like my entire, oh, it's done, it's done. My whole model, I can think everything is just like, a function from parameters and data to, loss or whatever. And like that makes it very mathematically, like patently obvious what's going on. Okay. This might be more than an hour. What the hell is going on? Yeah, like if I have to do this for every layer, have separate things, and then how does params know which ones to put where? Like what the? Oh, we're getting something. All right, so a linear layer, you start by creating these local variables in the function for your parameter, and then you return a function. Yeah, I mean, okay, excuse me. Okay, this is pretty clear to me. It's like I define some struct with parameters in that. This is kind of like I think there's some library like Equinox or something where like you define custom data classes for the parameters, and then you also have like call implemented on those. Could be totally botching this. I've never used it, but like it's similar spirit, I think, to that kind of idea. But dense. So dense is their built-in. Okay. Yeah, so this is what I really want. Okay. All right, this is easy. Okay. Import flux dense. Okay, and then dense of let's do like 3, 5. What do I get? Takes forever. Okay. Oh, 20 parameters. Oh, maybe it's counting like every weight as a scalar. Okay, let's get into this. So, and then d dot. What do I get? Dab, 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 dab. Bias weight and okay. 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 I wonder what or initialization is. What's my activation? Okay. Good. Good. I like that. I like that. So I guess I'll construct a model. And my model is going to be a chain. Let's get up in here. Um, they're just functions. You can compose them. Yeah, but then I have to code that. All right. Dense. So it's going to be 28 by 28 to, let's say, 24. Do some activation like, okay, now this is a question. Do I use, can I just write tan H? Or do I have to like sometimes you have to use their custom like ReLU, or whatever. I don't even know if that's implemented though. Yeah, but tan H. So if I want to get rid of it, where do I go? Do I implement it myself? Does Flex provide it? Like dots. Oh, they do. Okay, maybe I'll do that. All right, value. Okay, so far so good. And then 1024. Um, it does feel like so, 2018 that I have to define the inputs and outputs. like this has to be consistent with, oops, with this bit right here. But that's okay. Okay, let's do a few layers. Then dense 10, 1024 to 10. And no activation. Should we do like log softmax? I think, yeah. They have that log softmax. No, they do. All right. All right. So good. Log softmax. Boom. And log softmax. Okay. Oh, actually, this is really neat. I really like this. This is so cool. They show you, yeah, this is so handy actually. Like I can tell exactly where the thick parts, the thick boys are in my model. I know how many parameters is in total. I'm like, oh, if I send this to a device, it'll be, 15 megabytes. On the other hand, ooh, am I doing this in float 32? Like, what the fuck is dot weight? Yes, it's in float 32. How would I, like, let's say I do one layer in float 16. How do I do that? Okay, I'm not going to mess with that. I assume it's really painful and horrible, but I have no idea. Um, okay, so let's get some random data here. So random batch is, let's just start with like, okay, let's do some batch size. Let's do something small for now. 5 prime. Okay, and then we'll do batch equals rand n of how do I do this? What, just 5 by 20 by 28. Let's do that. Okay, I like that. But I want this to be float 32s as well, since everything models float 32. So I think I do like this. Ooh, so good. All right. Now, one thing that I really bugs me um, about Pluto is that I need to set a random seed. So I want to do like random, random.seed up here. But the problem is, and I need to random. But the problem is, um, um, there is no, like normally I would do this as my script, but like in Pluto, evaluation is not top down. So like I can write a cell above here that depends on D dot weights, right? And so it actually is evaluating this cell and then evaluating this cell. I have no way of knowing, like this is applied to everything that has kind of global mutation, but especially in this, I always need to set random seeds basically all the time to make my scripts, halfway useful. But yeah, where do I put, like, how do I enforce this to be at the top? And I'm not going to go and edit the underlying, like, I'm not going to change the, I know you can open up the file. I'm not doing that. All right. Yeah, so like if I run this again, I get, ugh. Okay, let's like this. Come down here. And, oh, just lost it. All right, well, random.speed. Let's do that. Okay. All right, good enough. We can delete. I don't know. So I have like a dark mode, dark reader on, and it fixes this one, but it doesn't fix this one. What's up with that? Okay, how much time do I have? Oh, we're not. Okay, 42 minutes. All right, we're gonna move on. So I can do model, and then what happens if I pass batch? Run batch. A dimension has, but B has dimensions that. Oh, that's interesting. So it wants to do batch dimension on the end. What? Why? That makes no fucking sense. Well, maybe there's a reason. I guess it's just a matter of convention, really. But it's just the opposite convention of what everyone else does. Batch size. No method match. Ah, Jesus Christ. Okay, see, this is this is why I don't do this. What is what in the world is this? Similar, float 32, float 32. This is a very benign, like, I don't think I screwed anything up here. Like, just copying straight out of the docs. I'm not even training yet. I'm just trying to run it on like just random data, and it doesn't work. Okay, it has something to do with log softmax. So they claim. Uh, what? Similar. Float 32, type float 32. I mean, I guess part of the problem is I don't really know what any of this is supposed to do. Like similar, create an uninitialized mutable array with the given element type and size based on the given source array. The third elements are both optional. Oh, okay. So I'm asking for something similar to a float, but similar apparently works on arrays, I guess. But I don't understand why that's an so similar. So let's say a float f2. Can I do that? And type. I think I can do that. No, I cannot do that. Uh, this stuff is such a mess. Okay. Oh no, that's what that is. Got it. Right. No, that's no good. So they want it like that. Right. Okay. So now we're matching that error. Okay. My hunch here, which I don't know if it's correct, but my hunch is that log max takes a vector, right? It doesn't take. It's not element wise. It takes a vector because the softmax option is like a function on vectors. I think the problem is it's trying to apply it element wise. So that sucks. Um, but then the question is like, Jesus. Okay, well, let's get some crap out and then let's try to do this manually and see what happens. So now I do that and it works. Okay, now log softmax on that. What does that do? Oh, that works. Okay, what? How does that make any sense? Because my understanding, based on the documentation, I don't know if that's big enough. Maybe a little bigger. Um, Based on the documentation itself, it says that dense is basically implemented. Congratulations, you just built a dense layer that comes with flux. And it just does, oh, well, they don't say how they do this, but I'm assuming it's just you apply that function. Oh, maybe they broadcast it by default somehow. But like the broadcasting is weird. Okay, all right, whatever. Okay, So the way to do this then is just to do log/max and then lib.log. Yeah, okay, now I don't want to be a pain in the ass, but like, what is nnlib and where is that coming from? Like why? I mean, um, I kind of know that Flux is sort of this agglomeration of like other random shit, and nnlib is one of those libraries, but if I didn't know, I would be confused there. All right, okay. Now we want to write some loss function. Loss over x's y is going to be so I have to remember how all this crap works. I think we're just going to do model on x's, and then we just element-wise multiply with the y's, assuming the y's are one hots. And then I think we just sum that up, right? Let me GitHub, Jax, MNIST. Shows what I know. How do you implement cross entropy? Come on now. Yeah, yeah, I'm not crazy. All right. Oh yeah, and that's a good point. I should use mean here and negate it because you could have different batch sizes and all. Okay, mean and negate it, and we're done. Okay. Now let's try loss on a random batch. Oh, Jesus Christ. Okay. Oh, no, that's my own problem. Okay. The problem I did there, this needs to be, how do I do rand? I do this. And then it needs to be batch. How do I get out here? Like, so X is going to be 784 by batch. So I guess the model on X's on random batch. I kind of wish Pluto just auto when I started typing, but did that. I mean, it can get annoying, I guess, if it's too eager, but it's kind of it would be nice. Okay, 10 by 5. Yeah, okay, right. So then this would be 10 by batch size. Mean. Okay, how is mean? I've actually run into this before in Julia. How is mean, you know, not in the standard library. All right. Statistics mean. I think that should do it. Actually, let's avoid a dependency here. Right, mean of x equals sum of x over, I think, num elements. Let's test that. Rand 2, 3, 5. Oh, okay. 3, 3, 5. And that is 30, which is correct. Okay, okay, so that's right. Great. Delete. Okay, so everything looks good to me. Let's try and get a grade because, after all, this is machine learning. Ooh, 30 minutes. All right. Okay, so the claim here is that I can just kind of use. I kind of make this bigger. I don't know if you guys can see anything. I can just call gradient, and Zyga will do everything for me. So yeah, docs here they use this params magic, which makes no sense. And then, but that's if you explicitly define your parameters. And I'm assuming like the W and identifiers here are actually referencing ones here. It's not clear because they're separated into two different code blocks. But I mean, otherwise this would just throw undefined identifier. But how do I do that for these layers? Because they're trapped inside the layer. I'm sure they have this box. There's what? I just want okay, all I want in life is like gradient of model. Okay, we need to find different docs because um, um, yeah, oops. Um, um, building simple models, building layers, recurrence. No, that's not what I want. Uh, loss functions. I have loss functions built in. I actually think that this is kind of feature creep. I'm kind of sold on the whole Jax thing now. Where like Jax is good because it's like three things, maybe a little more. I don't know exactly, but there's like a few fundamental blocks, and then you can do like all those building blocks components. Right? So I have grad, I have VJP. I mean VJP grad is VJP, but whatever. And you have VMAP, and like you can just do everything with those, everything, and then all the other crap on top of that is implemented via like libraries, right? So like there's tax for optimization, and so like you could have a loss function library for losses. Like I don't, to me, like yeah, even layer primitives are not built into React itself because like they had like an experimental one and they were like, listen, we don't know if it's the right thing, and like I think that's a really like wise choice because like it's hard to innovate on multiple things at once and like all needs keep changing all the time, like models change, blah 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 blah. Okay, but what I really want to get here is like how do I? Oh, and regularization. Why is regularization in here? Because I just implement regularization as like, right, like I don't really see what the value add is on that. Uh, uh, um, advanced model building. Oh God, where's this go? Oh, maybe this is part of the key. I can do params train. Okay, so this actually looks like we're getting somewhere, but it also makes me wonder. Oh, this answers my question. Why freeze layer parameters? Yeah. Okay. Great. Great. Um, oh, nice. Me likey. Yeah. Another thing that there's just no way it's going to happen on stream, but like there's so many things here. Like this is just all doing it on CPU, which is easy mode. And the real challenge is like, can you do big models on a GPU and will it work and be competitive? Especially if you have like multiple GPUs or like, people are doing like model parallelism these days. Like so many things that yeah, I don't think we're gonna get to that, but that's okay. Um, I just want example code. I don't want this. I just want show me, give me a gradient training. Oh, here we go. Flux dot gradient parameters do loss. This is weird, but that's okay. But where do my parameters come from? This is another thing I think is kind of easy pattern. Like I don't uh, like let people write their own training loops. It's super easy to write, and everyone's training loop is a little bit different. There's no reason to have like this kind of smells like RS to me, which is like total shit. So like it's just I don't know. And like I know you're putting in a callback function, so I can do own logging. Like what if I want this to go to weights and biases? I want to log to a file. Like still, it's just I'm not sold. Uh, but the good news is that like removing code is easier than putting it in. Okay, but how do I just want like maybe I need to kind of put two things together here. I need to, yeah, this is another thing where like this would just be options in the Jack world, at least at the time that I'm doing this. Uh, I think, how about this? So I think what I need to do here is flux.parameters, or something like this of model, params. It was just, there we go. So this, okay, now we're cooking. So this is giving me, I guess it's some function that reaches in through the whole tree. So this is like some tree of structs, and it reaches through the whole tree and pulls out all of the weights. Um, and then, yeah, there's kind of this magic bit where I hand that off to let's go back here. So I have that. Can I just do this? So grads equals flux gradient. There's no way this is happening. Yeah, well, maybe 25 minutes. All right, grads equals. Why can't I just do like value and grad in the Jack's world? Grads is flux dot gradient. Yeah, so this is another thing. Like, what's the difference between flux dot gradient and zygote gradient? Because the other docs led me to believe it was all zygote, right? Flux was just a way of doing things that under the hood zygote. But now, like flux its own gradient function, like that, that doesn't make sense. Flux dot params of model. Let's see if this works. And then we just do our loss. It's just loss of, and let's do random batch. And where's my, oh, here. Random, let's call this random x's. Let's call this random y's. Okay. Okay. Random x's. We can delete this. I wish there was a keyboard shortcut. Maybe this exists, and I just don't know. But I wish there was a keyboard shortcut and go to cell, because it's going over here to this thing is so it's so annoying to switch to your and then okay. Flux params model. Right. Okay, great. Okay. Random batch random. Oh, this is random x's, random y. All right. Not bad. What it's taking its time. It's just compiling, I guess. All right. Okay. Jax is slow to compile. This is another level. I guess. Oh, there we go. I guess this is doing source to source, which maybe. Yeah. Why isn't it showing me what's in grads dot 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 is not very. But that's okay. Also, I would have expected this to be a similar type to this, right? Because mathematically, I should have, I take my parameters, some type, like let's say it's a vector. The gradient should be a covector of the same type, right? So you should have a co-params or something. I mean, it doesn't matter, right? But like, it should be a vector. I should get a vector, or some people just give you a vector back, and it's just implicit that it's a covector, and that's fine. But this is a whole different type entirely. I don't really understand its utility. Like, why? What is graphs? grads dot grads is not defined. Oh, grad. What do we got in here? Grads. Gotcha. So this is where all my stuff lives. And then this, what is this? The original parameters? Why? Why would I ever want that? I guess what they're saying, oh, I guess they're doing something really weird here where like I think the params is a pointer to the memory of like the actual weights and biases. And for example, something like flux update is actually going to do that in place. And so, but you're passing in the parameters here anyways. So actually, I don't know. I take that back. Okay, that makes no sense. Flux dot optimize dot update. I need an optimizer, and then I need my params. Okay, this is getting messy. Let's do a begin. Let's call these params. Params. Params, and grad. I actually don't need to begin it. And we need to find our optimizers. Let's go up here. Yeah, I assume there's keyboard shortcuts to do things in Pluto, but I don't know. I wish there was a way. Can I? That brings up help. No. What does that do? Leave site? No. Cancel. Okay. Opt equals. Okay, now I need to get an optimizer, so I'll pull out one of these bad boys. Descent. Okay, so this is like SGD. How do I get Atom? Okay, just like that. That's easy enough. Flux dot optimizer at optimize dot. Okay, params not defined. Params are defined. It's defined right here. What? Okay, Pluto, you got bugs. Oh no, I didn't. I did that. There you go. Okay, swag. Okay, now what just happened? So this is giving me. It's updating all these things in place, which I'm not super fond of. I much prefer the XLA, JAX XLA thing, where it's like logically my program is purely functional, and XLA does optimization to like do mutability where it makes sense. Um, so like I don't even have to think about this because, for example, let's say I want to take a, I wanted to do some model where it's like, like meta learning thing where like I'm doing SGD over SGD. Like this would be mutable, and it's not clear to me that I'm going to get correct gradients if I have mutation in my program. I mean, even if Zygo can handle it, I'm not convinced I mentally have the capacity to reason it in a mutable way. I don't trust like that. All right. But I guess that does what I want. Like we have accomplished kind of the goal. We just need data now and like an evaluation loop and all the other kinds of standard things. Um, uh, let's do a for we get data. Let's do random data first. So for 1 to 100, Let's get a random stuff. Oopsies. Let's select lines. It's not compile apparently. Okay. Go here. Um, X's and Y's, and we'll just do X's, Y's. Let's move this cell here, since it logically belongs there. And then we'll just take this and put this in here. And yeah, so everything's in place. So programs is just updating over and over and over again. One thing that I really like here is I'd like it, so I want to, let's say I want to do something simple like, print my loss, like, show loss equals something. Batch loss, let's say, equals, I don't know how to do value and grad. Like, do, the gradient, it has to do a forward backwards pass already. So like it's most efficient to do a forwards pass, calculate, and do your backwards pass, and do it all in one swoop. Let's see how we do that. Flux.jl, value and grad. Basics. Auto grad in Flux. Need convenient utilities for looking inside grads. Me too. Me too. Yeah, how to do gradient clipping. Yeah, those are all like, yeah, I have no idea how to do any of that. I imagine, actually, I imagine it wouldn't be too bad, right? Because I can, as long as I can intersect into what grads is, I can maybe fiddle with stuff before I hand it off to the update function, which is okay. But I like that this is a relatively opaque type to the user because it would be nice, like in order to do gradient clipping, I would grad clipped, but then I'd construct my own grads here, grads of, and then I'd have to do my own stuff. But I don't know. I don't really see any docs on how to, that seems like it's not really exposed to users or intended to be instantiated by users. Yeah. Okay. Promise I'm not an idiot. uh, sure, there's a way to do this. I mean, come on now. Maybe in these docs, I'll show an example. Da, 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 da. Optimizers. Update. Carl. Training. Grads. So, yeah, what's going on here? Why in the world do I need this function or macro, whatever? That custom training loops. Okay, here we go. Okay. Custom training loops. So I don't like this. This is kind of gross. I create a local function so I can use it here, and then I assign to that function and then return it. I mean, that's just messy. Oh, zygote.pullback. That's what I want. Oh, that's much better. Okay, so then I have to call it manually, which is not the end of the. Okay, all right, we're getting somewhere. We're getting somewhere. Zygotes. Oh, I need to zygotes. Mm-hmm. Um, let's do this. So I have no idea what I'm doing. Okay, so I go to gradient. Oh, yeah, right. Um, Actually, let's see what Psycho gives me. Gradient, pull back, push forward with gradient. I wonder if it's with gradient. Can I do that? Returns both the value of the function and the gradient. That's what I want. All right, now we're making moves. Okay, so value and now, ooh, yeah. All right. Now, uh, yeah. Okay, this is so strange to me because intuitively, like mathematically, when I take a gradient of a function, it's with respect to an input to that function. But here, what is my input? What do I put in here? Weights? Params? No, because loss is implicit in params, right? I can't, it's not, it's not like Jax where I can do that. Um, and so in the docs, they literally just do a thunk. Uh, uh, well, yeah. I mean, I guess it's cool that this works at all, but it's intuitively for me, just for what I'm used to, it's confusing. That's no hate, you know. All right. Okay. Random x's, random y's, and then and then we need to give a right. We need to give it's a function that takes some input x, and then you need to evaluate your gradient at some point. But like it's not clear where it intuitively is going in here to go in there, but it's not explicit uh, in the actual code itself. So there's a lot of magic around here. There's a lot of there's a lot of things that we're not seeing kind of happening. All right, so but params. Oh, look at that. It worked. Oh, it worked. Oh, that's really good. Okay, finally. All right. Boom. And then this is going to be y's and x's. Okay. And this is going to be nabla. That's that. And now I can print, you know, let me do this in Julia. Loss equals v. I'm rusty. To the sign. Something's wrong. Da. That worked. 1 plus. That did not work. Vector syntax. So like this. Ah, it is that. Okay. It's not syntax highlighting for some reason, but oh, yeah, this is annoying. I can't. These lines end up over here. Also, why is it? I may not understand these backticks. I thought this was supposed to be a string interpolation, but I think it may be doing some kind of other nonsense. Yeah, yeah, it's constructing I guess a symbol, maybe some Lisp nonsense. All right, not that would explain why the highlighting was. All right, so we are not going anywhere good, but that's random data. Okay, I guess let's get MNIST data. That's the next step here. Training models, data sets. Yes. Data loader. Uh, okay. Well, this doesn't really help me. Uh, Well, it's good docs. It's just not the docs that I need. I need like, MNIST, right? Like basic common data sets. Utility functions. Oh God. It's in here. One sec. Oh, okay. I see. Yeah. Um, performance. Ooh, this is going to be interesting. Don't use more performance than you need. Evaluate batches as matrices of features. Oh, so this is a question I have also. So Julia is cool and then it has forecasting built into the language. So, for example, I can do sine of 3, or I can do I can broadcast this over 3.3, 5, uh, 11, and the broadcasting will automatically just take sine and I'm assuming it's using nice SIMD instructions on my CPU. Um, I also assume that on a GPU it would do nice uh, things. Like my hope is that I could, one of the things about Jax's VMAP, I can take dot product and reconstruct fast matrix multiplication with no loss in performance, just by using VMAP, right? I just do a bunch of VMAPs over, row, column, and then you can do that for matrix vector multiply, and then you can matrix multiply. This is in the Jax docs. It's really cool, right? And XLA under the hood will say, oh, matrix multiplication. It'll just recognize it. I hope, I would really love that for Julia to do something similar, where like, why do I pass in a batch to model? Why can't I just do like why does model accept this? Why can't I just do that and get the same performance out? This section of the docs implies that I cannot, which is unbelievable. It's very hard to accomplish this, but with all the new like meta theory and like, I mean, if XLA can do it, come on. I feel like, Julia people are smart. Okay, but that's enough rambling. Let's get back on track. Um, oh, there it is. That's exactly what I want. ML datasets. Oh, fantastic. Ho, 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 ho. Ho, 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 ho. Yes, that's what I want. Okay, perfect. All right. This is going to be the easiest part, it looks like. Import ML datasets. That. Okay, so I get train data, I get the test data. A color. I've never seen that word before. Okay. Okay. Uh, so train data, train Y, are these like the labels or are these? It doesn't really say. Also, once I have this, I need to convert it into batches, which I assume I can use the data loader stuff. We're all done. Okay. Okay, let's try using this. So um train train Y equals ML data sets dot um objects of type. Oh, I need to do dot data. It's going to complain I have it. I mean, this is confusing, but I think it's because I don't have it downloaded. I wish they would put this in the docs because, I mean, yeah, how am I supposed to download this? MNIST.download. All right, that's it. ML datasets dot MNIST dot download. Nope, nope, that's no good either. Could not open stream. Accept terms? Oh, Jesus. Do you want to download? Oh, okay. This is all right. This is fair. I understand why this is doing this. It's not Pluto friendly, um, but maybe we can uh, maybe we can make it work nonetheless. Um, cd dev shell Julia. Um, do actually this is tricky. Tricky. So Pluto for each notebook, if I understand correctly, Pluto for each notebook has its own um, Julia project with its own project.toml, its own manifest.toml. So it's not using anything in my base install, but as a result, like how do I download this shit? I hope that there's a auto like I have a thing on here. I accept views, yes. Uh, or the environment variable. The environment variable. Equals and then download. Okay. Okay. Now we're in business. So close. Okay. So it's downloaded. Swag. Now, oh shit. Let's do that. Cannot open stream. Oh no, it's loading. Okay. Great. Um, uh, okay. This is a chunky, but what am I looking at? This is clearly image data, right? So, oh, end of the hour. Okay. Okay. I'm not gonna spend time on this, um, but actually, I do sort of see like the next step is like you just sort of pipe this data through it and create a training loop. Cross your fingers that everything works. Um, so yeah, all right. That's my experience trying to use Flux. Um, better than I expected, I think. Previous experiences with Zygote, I had a bunch of like, well, I correct gradient errors, which kind of is like, it's kind of like you have one job, right? Like, it pissed me off so much that I've never used it since then. Um, and of course, we know knowing that these gradients are correct, that we just use them. But assuming they are, this was unexpected. But like, there's so many other things that, it took an hour to do this. Where like in Jax, I could have had an implementation. I mean, also this is partly because I know Jax, but like uh, much faster, and it would have worked on a GPU. I don't know what the situation is with this in CUDA, but I'm just less optimistic. uh, I mean, maybe it just works. Maybe it works out of the box. I have no idea. But now, um, yeah, I guess that about wraps it up. This is the only stream I've ever done in my life, but it's kind of fun actually. So yeah, I don't know if there's other picture stuff you want me to try and implement in Julia, or maybe like in Dex. Fun. Um, yeah, consider it. All right. How do I quit this thing?